Okay, tatalakay naman natin ngayon ang Squeeze Theorem, which is important in deriving the special limit para sa trigonometric function. So, Squeeze Theorem is basically evaluating the limit of a function, say b, as the variable v approaches a certain value k, such that b is within a given boundary a, c. If the limit of a and the limit of c as v approaches k is equal to L, then the limit of b is equal to L. So, that is, so kung ang limit ng function a and c ay parehas na L and b is greater than equal to a but less than c, so kung ito ay 3 and ito ay 3, so since less than equal to, so to make this true, dapat ang limit nito ay equal sa 3. So that is Squeeze Theorem. So this is vital in deriving this limit of sine x all over x is equal to 1 as x approaches 0. So again, kapag ginamitan natin siya ng direct substitution, magkakaroon tayo ng sine 0 over 0. And we know for a fact that sine 0 is 0. This is over 0, which will turn to an indeterminate form. So, since indeterminate form yan, hindi tayo makakasolve, hindi tayo magli-leave ng answer na ganyan. So, anong gagawin? So, pwede tayong gumamit ng table of values tulad ng ginawa natin last time. So, pero dito, pwede natin siyang i-derive gamit ang Squeeze Theorem. So, relating the areas as shown. So, since this is a unit circle, alam naman natin that a unit circle is a circle of radius 1. So, this distance from this center O to this one is 1. So, this distance to that point is also 1. So, we have here area green, area orange, and area yellow. So, this is a triangle, this is a sector, and this is also a triangle. So, let us try to find the area of the green, area ng orange, and area ng yellow respectively. So, punta tayo muna sa area ng green. So, ang area ng green, since this is a triangle, 1/2 base times the height. So, if I am going to draw from that point, perpendicular to the x-axis, so makakakuha ako ng altitude which represents the height of this triangle. So, kung i-relate natin siya sa triangle, so this represents the angle, this is the height, and this is 1. So, para makuha natin yan, so gagamit lang tayo ng Sokatowa Chiyo Shakaw. So, means sine of x is equal to opposite over adjacent. Over hypotenuse. So, opposite to x is h, and opposite to hypotenuse is equal to 1. So, then h is equal to sine x. So, that's why we have 1/2, base is 1, height is sine x. How about this area ng orange? So, area ng sector is 1/2 r squared theta. So, that's 1/2. Since radius is this distance to this point, which is 1, unit circle, so 1 squared multiplied by theta, which is x. So, then area of yellow, so this is yellow, is also 1/2 base times the height. So, this represents the height of the yellow triangle. So, ang gagawin lang natin is, gagamit tayo ng principle ng tangent. Tangent of an angle x is equal to opposite over adjacent. Opposite to x is height, adjacent to x is 1. So, therefore, h is simply tangent of x. So, again, 1/2, base is 1, height is tangent of x. So, simplifying, we have area green is less than area ng orange, of course, kasi nga, pag isinade natin itong portion na to, magiging ito na. So, therefore, area ni green is less than area ni orange. And since meron pang additional shaded dito, so that must be less than area of the yellow triangle. So, relating their areas, so magkakaroon tayo ng 1/2 sine x is less than 1/2 of x because 1 squared multiplied by x times 1/2 is 1/2 of x, and area of yellow is 1/2 tangent of x. So, if I'm to simplify this by multiplying this all by 2, so this gives us sine of x is less than x is less than tangent of x. So, if I am to divide this all by sine x, bakit yon? Kasi ang kailangan natin is the ratio of sine x over x. So, dividing this all by sine x, magiging 1 is less than x over sine x is less than 1 over cosine of x. Bakit naging 1 over cosine of x? Kasi alam natin na ang tangent is sine over cosine of x. If i-divide pa natin siya sa sine x, that sine x cancels out with that, giving us 1 over cosine of x. So, since we need sine x over x, taking its reciprocal, and one property ng inequality, kapag kinuha natin ang reciprocal, the inequality sign ay magre-reverse. So, magkakaroon tayo ng sine x all over x greater than cosine of x. So, 1 is greater than sine x all over x is greater than cosine of x. So, taking the limit of each term as x approaches 0, limit ng constant as x approaches 0 is still a constant, which is greater than limit of sine x all over x as x approaches 0 is greater than limit of cosine x. So, since 0 is part of the domain, pwede ako maglagay ng cosine 0, function value. So, this is 1 greater than limit of sine x over x as x approaches 0 is greater than 1. So, using Squeeze Theorem, so for this to be true, limit of sine x over x as x approaches 0 is therefore equal to 1. So, that is the derivation kung bakit ang limit ng sine x over x as x approaches 0 is equal to 1. So, we can use that na sa mga susunod nating isosolve. So, how about limit of 1 minus cosine x all over x, and that must be equal to 0 daw. So, substituting cosine x is equal to 0. So, magkakaroon tayo dyan ng 1 minus cosine 0 over 0. Again, cosine 0 is 1. So, magiging 1 minus 1 is 0 over 0. So, pagka direct substitution, magiging indeterminate at hindi tayo magli-leave ng answer in indeterminate form. So, we have to make a way para ma-solve ito. So, anong gagawin? We can simplify by multiplying both numerator and denominator by its conjugate ng numerator. So, pag minultiply natin both numerator and denominator by its conjugate, so again, ang gagawin natin dito, tatanggalin natin yung indeterminate form. So ang solution is, i-multiply natin sa conjugate. Bakit kaya minultiply sa conjugate? So, we know for a fact na kapag nag-multiply ako ng a plus b by a minus b, ang magiging sagot natin ay a squared minus b squared. So, in that case, pag minultiply natin siya as x approaches 0, magiging 1 minus cosine squared of x all over x times the quantity 1 plus cosine of x. But, sabi ni trigonometric identity, sine squared theta plus cosine squared theta is equal to 1. So, if I am to transpose that cosine squared on the right, so this numerator is simply sine squared theta. So, this gives us limit as x approaches 0 of sine squared x all over x times the quantity 1 plus cosine of x. But then again, sine squared x can be written as sine x times sine x. So we can rewrite this given as sine x over x multiplied by sine x over 1 plus cosine of x. So again, pag sinimplify natin to, sine times sine is sine squared, x times 1 plus cosine x is x times 1 plus cosine x. So this is still the same as that of our given. Using limit of a product, makukuha natin that limit sine x over x as x approaches 0 multiplied by limit sine x all over 1 plus cosine of x as x approaches 0. So, substituting, this is 1 from the what we have derived kanina. So, this is 1 sine of 0 over 1 plus cosine of 0. But sine of 0 is 0, cosine 0 is 1, 1 plus 1 is 2, 0 divided 2 is 0. Thus, limit of 1 minus cosine x over x is equal to 0. So let us try to apply these principles to solving this succeeding examples. So we have limit of sine 5x over x as x approaches 0. So from what we have derived kanina, we have limit as x approaches 0 of sine x over x is equal to 1. So meaning, kung ano yung angle dito, dapat yun din yung nasa baba. So, ibig sabihin, if this is 5x, dapat meron din ako ditong 5x sa ilalim. So, how or paano ko siya magkakaroon ng 5x din sa denominator? So, kailangan ko lang mag-multiply ng 5 sa numerator at mag-multiply ako ng 5 sa denominator. So, pag ginawa ko yon, magiging itong limit of sine 5x multiplied by 5 all over 5x, because this 5 multiplied by x is 5x as x approaches 0. So again, using limit of a product, magkakaroon tayo ng limit of 5 as x approaches 0 multiplied by limit of sine 5x over 5x as x approaches 0. So meaning to say, same na yung angle nito. So that gives us equal to 1. Limit of 5 is a constant as x approaches any number. So this is 5 multiplied by 1. So the answer here is 5. So, example number 2. We have limit of sine 2x all over sine 4x as x approaches 0. So what will we do is using limit of a quotient. So that is quotient of their limit. So this can be written as sine 2x as x approaches 0 all over limit of sine 4x as x approaches 0. So para magamit natin to, kailangan magkaroon ako ng 2x sa denominator. So para magkaroon ako ng 2x sa denominator, magmumultiply ako both numerator and denominator by 2x. Similarly, para magkaroon ako ng same denominator, maglalagay ako ng 4x sa numerator, maglalagay ako ng 4x sa denominator. Yeah, I do that, magiging limit of 2x sine 2x all over 2x as x approaches 0 all over limit of 4x sine of 4x all over 4x. So which is equal to limit of 2x as x approaches 0 multiplied by limit of sine 2x over 2x as x approaches 0, all over limit of 4x as x approaches 0 times limit of sine 4x all over 4x as x approaches 0. Since this is equal to 1 and this is equal to 1, magkakaroon tayo ng limit of 2x all over limit of 4x. Pag sinubstitute natin, magiging 0 over 0, indeterminate pa rin. But this can be written as limit as x approaches 0 of 2x over 4x. And 2x over 4x is equal to 1/2. So, limit as x approaches 0 of 1/2 and limit of a constant as x approaches any number is a constant. So, therefore, this is the answer to the limit of sine 2x over sine 4x as x approaches 0. How about limit of 1 minus cosine x raised to the second power all over x? So, meron tayong na-derive kanina that limit of 1 minus cosine of x over x as x approaches 0 is equal to 0. So, with that, pwede tayong maglagay ng x sa denominator para meron tayong square din sa taas, may square din sa baba. So, para magawa yon, magpumultiply ako ng x, magpumultiply ako ng x sa denominator. So, giving us limit as x approaches 0 of x times 1 minus cosine of x squared over x squared. Because x times x there is x squared, and that x here, ilalagay lang natin dun sa unahan. So, magiging limit of x as x approaches 0 times the quantity limit as x approaches 0 of 1 minus cosine x raised to the second power over x raised to the second power. Diba, meron tayong principle na kapag ka-exponent, pwede natin kunin ang limit ng function at saka i-raise natin sa exponent na yon. So, this can be written as 1 minus cosine x raised to the second power. But since this is 0, raised to the second power is 0, and limit of x as x approaches 0 is 0, 0 times 0 is 0. So therefore, that will be our answer there. Then, what if I have here cosine x minus sine x minus 1 all over 2x as x approaches 0? So, we will have limit as x approaches 0 of the quantity. We can combine cosine x minus 1 over 2x minus sine x over 2x. Since meron tayong principle kanina na sine x over x is equal to 1. So, ang gagawin lang natin, ilalabas lang natin yung mga constant outside. So, using this principle also, dapat negative yung cosine, positive yung 1, I can factor out negative 1/2. So, this gives us negative 1/2 limit. Pinactor out yung negative, magiging positive yung 1. Pinactor out yung negative, magiging negative yung cosine of x. All over, nilabas yung 2, kaya x na lang yung ilalim as x approaches 0. Minus 1/2, kasi may principle tayo that limit of sum is the sum of their limits. And so with the difference. So the difference of their limit. So this is minus limit of sine x over x as x approaches 0. So we know for a fact na kapag ka may constant, ilalabas lang natin siya dun sa limit operation. This is equal to 1. This is equal to 0. So negative 1 half times 0 is 0. Negative 1 half times 1 is negative 1 half. Therefore, this is limit as x approaches 0 of cosine x minus sine x minus 1 all over 2x is equal to negative 1 half. So this is the special limit theorem for trigonometric functions.